follow there. So if I have 10% of those questions, I'll be fine. How did I get here? Essentially, I went to the National Open Access meeting, my first appearance there, and Mary invited me to speak here. So that's been my most successful collaboration ever, one meeting, and suddenly I'm invited to give a talk. Essentially, what I want to do today is just basically to talk about the last 10 years when I've been working with the EPA, and has anything changed? And suddenly when I was doing this presentation, I said this might be a point in my life where I'm starting to feel a little bit old, where I'm looking back and saying, what are the young people doing nowadays? And I was that person maybe 10 or 12 years ago when I started in this area. And I suppose what I want to try to look at today is what has changed over time and what's left. What are the big questions that we're facing at the moment? There is supposed to be a little line through here. It's nice to see this diagram. In 2004, we were drawing similar diagrams to this, saying that if we could get research results, we would try to disseminate them as widely as possible through different means. Now, we didn't have words like gold or green, but this concept of access, free access, restricted access, was certainly in our minds at the time. Now, if we just go back to 2004 to try and set the context, and I know this can't be read here, but just to things that happened in 2004, Athens had the Olympic Games, for example. Lord of the Rings, imagine, won Best Picture at the Oscars 10 years ago. And then for the Irish in the audience, Brian Cowan became Minister for Finance, and that's begun a fairly strange part in our history. Twitter hadn't even been born. Twitter was still 2 years in the waiting. Deaf Facebook was around at that time. YouTube looked like that. And the Android, the iPhone hadn't even arrived because we were deeply in love with the Nokia 1680. But then at the same time in 2004, some authors were saying, okay, let's stop for a minute. Enough has happened. We need to start thinking about metadata here. Things are getting out of control. There's a lot of data being generated. There's a lot of calls for more access to data, more distribution, and we need to stop and think about what we're doing. So this was kind of at the time where Dublin Core was getting, proper IT implementation. ISO 19115 was coming in for geographic data sets in a big way. And it was time to say, okay, where's the problem coming from? Is it from the systems end where there's no support for metadata, or is it from the people end, or is it both? So at the same time then, the funding of environmental research was actually undergoing great changes here in Ireland at the time. The EPA were given a fairly large budget in Irish terms to manage an environmental research programme, and that would widen the remit of research in Ireland, and crucially it would try and get research done that linked directly to policy and the current needs. So you'll find that climate change was a big driver in 2004 because you were coming out of the beginning of the implementation of the Kyoto Protocol stage. So climate change was a big word. It still is now, but it was one of the first ones. So that's the link to policy. So what there would be needed would be a scaling up of the funding allocated to the environmental research. Now that's what the webpage looked like in 2002, just explaining about this program, about the calls, about the rules and regulations about the calls. That's what we look like in 2004. Again, similar now, there's been 230 projects funded. And then in 2007, the ERTDI program came along, which was the biggest program yet. Now, obviously, everyone understands this project life cycle. Just to put this in context, when we were looking at the projects, we were saying that the EPA award funding for a project, the project happens, the project finishes. Now those projects can be anything from short scale studies of 6 months up to large scale to 5 years. And then there's this 1 or 2 years afterwards where the reporting is done, where reports are generated, where papers are generated, and then the relationship between the researcher and the EPA essentially finishes. Now data was the weakness in that whole thing there. That yes, the EPA were successful in funding environmental research. The capacity for environmental research was growing in Ireland very, very strongly. There was funded projects delivering deliverables, but there was no data, and that's the key. So this is what the integrated system looked like. You had printed reports sitting in boxes waiting to be ordered over the telephone. You had the web-based PDFs, and that's essentially the search. That's essentially the library catalog system. So all we were getting really in the end was a report. And I know this was moving a bit forward, but just getting PDFs was not really actionable knowledge. So I know these both look black and white, but you don't get James Cameron to make Avatar and then produce it in black and white in a flip book. You don't spend all this money in research just to get a PDF back. So what we did in 2004 is propose this radical, in quotes, open access approach to environmental research. That part of the contract with the researcher would be that they would provide us at the end of the project with significant data. So the word significant is important, that it's not every lab scribbling that was made over the project. It's what are the valuable assets from this project that the next researcher could use, and that the EPA would commit a long-term management to this data. So there's servers inside of managed server infrastructures. There's paying me, there's paying other people. This wasn't just something that was going to go away. So the radical approach then would link the reports to the actual data from those reports. Now, I know this is kind of common sense now, but back in 2004, this was pretty new, and it was pretty tough to stand up in front of an audience and sell this to them, because this will never work. This will never work. We have to see it in the context of the web of 2004. But researchers said, okay, we'll buy into this because, well, it's the only way we're going to get funding if we agree to the conditions of the contract. Once you give us a decent embargo period after the project ends. So we had a look around, we looked at all of the funding agencies. We said, okay, 12 months after project end, we'll get your data, we'll keep it safe, locked away, but then after that, it's going public access. The researchers also wanted access control, so that they'd have the ability to say, okay, file A is public access, but file B isn't, and then the ability to change them. So if they in the future wanted to add some more files or change something, they could do that. So we, or should I say I, sat down for about 6 months, and I wrote a data management system in Java, which I wouldn't do nowadays. It was a tough experience, but in saying that, it's still working. It was launched in 2006, and it's still here today. So that's one of my more successful outputs over the time. Safer's architecture is actually fairly straightforward. We have, at the back end, we have a MySQL database holding metadata. It's talking to the file archive, and then we have servers and bits and things in the middle, and then there's Safer at the front, and there's other tools there as well. But the nice thing about us writing this ourselves, the advantage to that, even though there's many disadvantages, is that we've been able to add on functionality as we needed over the years. So when people started saying, oh, we'd like to get a JSON feed off that, it was no problem. We could just add a JSON feed. The building blocks of Safer, this concept of a resource which is linked to kind of metadata, which is ISO 19115, but with Dublin Core obviously in there. You can't put files up on Safer unless you create metadata, and this has been the bane of people's lives over the last couple of years. Now, as a tool, actually, we feel it's been fairly successful. The numbers here are modest, I suppose, in terms of the big data numbers people throw around. But we're getting about 5,500 downloads a year. We like to say they're genuine downloads. They're not, counting Google sucking all these off your server every day. There's about 3,500 files or data sets that are publicly available. There's a lot that's still in the embargo period there. There's about 200 projects which are represented. Now, and then a USB full of data, but going from the last example there, we've some projects which the 1 megabyte file is a valuable resource versus the people who have produced 20 gigabytes of imagery. So, and the nice thing is Safer's actually, closed the circle on itself. The EPA are actually using Safer now to distribute its own data. Initially, it was just a research tool. So all of the EPA's archive of air quality data that they've ever had is on Safer. All drinking water data goes up there, completely open access. Greenhouse gas inventories, historical mines, things like that, all go up on SAFER. So the EPA just provide them open access. And what we try to do is we try to be collaborative with the researchers. So the researchers are given an account on SAFER early on in the project, and they're encouraged to create the metadata in good time, but close to the end of the project, and that there should be an ongoing process of uploading data. So I think there was a question there about how many hours should this take. The researchers are told that this is part of the reporting, just the same as their financial and time reporting is. The data reporting is part of their obligation. So to work that into their time workflow, so that the excuse of I don't have time to do this just doesn't wash, because it's not something that's sprung on top of you. It's written there in the terms and conditions. The steering groups from time to time will say to a project, we would like that data set to be open access, rather than just maybe the EPA saying it. So the international experts would say, we think that data set should be open access. And I suppose it's very hard to write a guide for SAFER, because one size doesn't fit every project. Some projects, it's just unfortunate, the graphics are getting a bit dulled out with the light here, but some projects are the big boot there, and some are the small one. Some are using Ordnance Survey data, some are using census data that have different licensing. We sometimes have to pull apart the data sets so that we don't get involved in putting licensed data up in the web, that there's not third-party data going up there when it shouldn't. And part of my job is sitting down with projects and discussing these things early on. Now, the problem is that there's actually still a disconnect between what we fund and what goes up in SAFER. If you can see this here, there's actually EPA funded over, well, actually more than 800, but there's 800 projects which have been funded over the value of €10,000 since 2001. And this is a little interface we have of just searching the metadata of the projects. And so we have 200 projects in SAFER. There's been 800 altogether. So this has brought us to the lessons learned, I suppose. What have we learned in those couple of years from that? That has anything changed? Well, as you can see, the numbers are not a one-to-one relationship. There is a change in terms of what I'd say, this term is going on, digital natives. So the young people. The PhD graduate now is coming through, and he or she is 22 years old or 23, 24, whatever. They're much more open. They don't seem to have a problem with open access and open data. If they're convinced that it's a good idea, it's us and others still have the problem. We're still finding it difficult to find the correct structures for open access, and I'll talk about that in a minute. But data management and making the data openly accessible is still a low priority for a lot of people, or it's misunderstood. Sometimes it's often that people might feel that the EPA want to get this data and use it ourselves and not tell anybody about it, when that couldn't be further from the truth. Metadata is still a mystery to most researchers. I gave a presentation at a workshop a few weeks ago, and I gave a talk about metadata, and a guy gave a talk about Inspire metadata. And I think at the end of the day, we sent everyone home confused more than they came in, because everyone has an idea of what metadata is. But at the end of the day, most people find it a bit of a burden and an annoyance, and it's a time-consuming task. Now, I've just gone through a process with EPA of Inspire reporting for air quality data, and believe me, metadata is not an issue until you get to Inspire, and then you really see what metadata is all about. I think the bottom line is there's a lack of appreciation of the need for metadata, that people don't think about the fact that you wouldn't find things so easily on Amazon if there was no metadata, but Google wouldn't find things so easily if there was no metadata. One of the things that we hear a lot about is that our project didn't generate any data or information that could be publicly available. Now, I'm not picking these two reports for any reason. Actually, both of these provided data. If you've written a report and published a report that has charts, tables, and analysis in it, looks to me as if there's data there. So maybe the people that are reading your report would want to get that data and use it to reproduce the results or build on the results. I think if one piece of technology has haunted me right throughout my career, it's Excel. Excel is still being used as a universal tool. It does everything. So people are using it to collect their data, to analyze, to visualize, to store it, etc., all in the one spreadsheet. And this is, it's no need to tell anybody, this greatly reduces the reusability of the data. Without writing a very, very detailed how-to guide to the spreadsheet or to the spreadsheets, it almost becomes useless the minute it's handed to us, because you're trying to like hammer in you know, the proverbial square plug into the round hole, really. And what we've tried to do is to sit down with researchers to discuss now data management plans, not maybe in the context of the Horizon 2020, but to sit down and say, okay, stop for a minute. I heard you're going to collect data in Excel. I can show you another way. And the idea is that if you're going out to monitor the number of people passing by this building every hour, there's objects that can be made into a database structure there. Let's not use Excel. If we're going out to monitor flow levels on the River Lee down there, there's a way to model it better than an Excel file. If we're looking at long-term distribution of this data and use. And not only for that, but then if you model it correctly, there's lots of other tools that are going to make your visualization life a whole lot easier and your analysis life a whole lot easier. At the end of the day, storing it, the storage medium doesn't care whether it's a poorly structured Excel file, but the people that will access it do. So the fear of allowing data to be freely and openly available is pervasive, and it almost stops, I think, some people actually, you know, making changes or thinking about how they would structure data. The problem is that we're often asked to extend embargo periods and extend, and you get to the point where that data almost dies, that it's so long in the embargo period, the journal papers are written, but nobody can get at it, that it has lost its value. So there's a quickly decreasing value on it the longer it's hidden. So just to finish off with some issues for the future that we're dealing with. I'm not sure how many know about Inspire here, or just it's the concept of a spatial data infrastructure for Europe, looking at trying to get all of the member states to represent data and metadata in the same way, so that we can, if we wanted to compare flow levels in a river in Ireland and Bulgaria and Norway all at once, that we could do that pretty easily without needing to be GIS experts. Now, I did say Inspire metadata is tough going, but I do like the way that observations and measurements, this international standard for modeling observations, has come in. And it's something that I say to some researchers to consider, that even if you were just to organize, if you want to do Excel and you can't be changed on, even if we could link the files in this way, so a simple example of doing some observation of, say, ozone. So ozone is your property. You're getting hourly values. What process did you use and what feature? So that's your geographical coordinates. If you were to even imagine that as 4 Excel files that were separated out, 4 objects, already you've made that data much more useful and usable. And then you can obviously imagine them as database tables, which would be better. And that can be scaled up then to something more complex. If you're modeling sea surface temperature, for example, and you're on a grid, no problem, this model still works. And it's actually, a nice way to do things. And obviously there's metadata for all of these different things, but at the minimum, if you could organize data a bit better, you increase its reusability. I also feel, and I think few people have mentioned this directly and indirectly over the days, that I'm a computer scientist myself, and I do a little bit of lecturing now and again, and I'm just feeling that there's, even amongst computer scientists, there's a disconnect between understanding a little bit about databases and metadata. I feel that part of a professional scientist training nowadays should be something related to data management. Now, this doesn't mean that you need to know whether Python or Perl is good for processing files of over 20 gigabytes or something. That's not it. It's knowing what a relational database is. It's knowing why you shouldn't mix data types in a column for dates. So you shouldn't use US dates and European dates and Irish dates all in the one column, because Excel allows you. That there's rules about how data is represented. One of the biggest problems I've encountered in seeing data over the years is, how do you represent, if you took a measurement of flow in the river and your instrument wasn't working, so you didn't get a value, is that 0? No, it's not 0, because 0 flow means something. It's not -1 either. Is it blank? Well, if it's blank, then the one you had with 0 a minute ago isn't correct. So it's understanding that there's ranges to quantitative values, and how that would affect someone analysing this in the future. A project I'm involved in, it's a large FP7 project. It's GIN2K. It's looking at taking a thing called a body of knowledge, which was developed in the States there about 10 or 15 years ago, and tries to align the GI science and technology industry with academia. So, for example, if you're an academic and you're going to teach a course in databases, it would be a set of suggestions on what your curriculum should include. And we were at a meeting recently in Lisbon about this, and that was something that came up. It's a little bit more about, don't forget, just because people are using lots of tools that make using other tools easier, you shouldn't forget that learning about a relational database is still very useful. Maybe learning about a NoSQL database is also useful. Now, again, you're probably not going to be able to read that, but how do we ensure that data access to the actual data sets, that we don't lose data? Now, it's a little bit different to the UCC presentation in that when I'm saying about losing data, in the past, again, let's go back to 2004. We're sorry, Peter, we had that data on a CD. I moved office. I don't know where the box is that I put the CD into, and the data's gone. So then there was stuff getting lost on zip drives. I remember using zip drives. Stuff got lost on network drives that you lost a mapping to and you couldn't find. Then we came along with USB keys. No, we had data for that. We can't find the USB key it's on. So we're still having the same problem. And I think today we have so much cheap storage. We don't know what to do with it. I got a shock when I took these screenshots the other day to think that you can buy 4 terabytes of data for 149. When we set up a server rack about 10 years ago, 149 wouldn't have got you an 80 gig hard drive to stick into the rack. So it's absolutely amazing. The problem is that with so many USB keys hanging around now, things get put on these keys and end up getting lost. Then you're going to the cloud. Stuff is going into all of these. It goes into these. Then people say, well, I have that in my iCloud, or have that in Google Drive. How do I get it to you? And then, so if someone goes away and forgets the group password for Google Drive or something, then you're stuck with data out there in the cloud that we're never going to be able to get at. Now, what we're trying to do in these last couple of slides is redesigning the whole architecture of SAFER over the next few months. And we're trying to optimize the reporting for projects. So what we're trying to do is that getting metadata from projects is proving difficult and has proved difficult. So what we're going to try and do is to get people to report metadata once. And we're going to try and reuse it as often as possible through web services and other things. And encouraging researchers to look at our options for storing data long-term as a good option, that there is sense to it, that that the rationale behind it hasn't changed from 10 years ago. Yeah, so things like this that we're trying to link to is again, it's another tool I've built, Catalogue of Environmental Research in Ireland. This is for people who are looking basically to extend to Horizon 2020. The idea is you set up a research profile for yourself. People search this. We're going to be making a JSON web service, so this can be sucked into other catalogs. But basically, if you had data on Safer, we'll get you a link onto here, which will automatically pick it up. So when your profile comes up, it'll say, oh, this person has data and stuff on Safer here. So we're crediting you with depositing your data, and other people can see that. We're also building and hopefully launching in the next couple of weeks a tool called Droplet, which, like the acronym of earlier, is a water-based acronym, but we see this developing and possibly someday taking over from Safer. The idea of it being a database of the data, of the metadata, and also for research funders to come in there and post research events, post research calls, and for this to be a more joined up type of effort. And to look at how we're presenting this. So maybe present the data in map-based form. So no longer, we're a long time typing into search boxes looking for projects. So maybe to some innovative ways to display these projects. So the final slide is that in summary, a lot has changed over the last 10 years. I look at digital libraries nowadays, and even as a computer scientist, I just still find it so amazing that you put a paper on the web and automatic systems can do citations, can do linkages to other papers. It's absolutely fantastic. But still, the very fabric of open access is researchers and scientists with their data. And I think the three key words is that there needs to be improved education about it. There needs to be consultation. So there can't be this disconnect between a funded researcher and the body that's funded them. And then at the very end, when there's a big hurry about getting final reports and stuff done, that people are looking for data. And then implementation. So come up with good plans and implement them. We're happy with how things have gone, but we're working hard to improve them. And I think that things will improve because the philosophy and the mindset in people and in researchers is changing towards open access, because all around us, this concept of openness on the internet is just, is closing in on us, so we can't run away from it. So I'm probably in time for a few questions there now. So that's my email if anyone wants to contact me.
Any questions?
Is the Droplet one just for EPA research or for all different?
No, at the moment it's actually for the Droplet in its first launch will be for any Irish research organisation involved in water-based funding, but we're looking to, so Teagasc Gardair, Enterprise Ireland have funded a few, COST, the commission itself actually, and a few others. But I think after the launch, when we do the water almost as a pilot, that it will be extended. So it has a water-based kind of team at the moment, but it's flexible enough that it should be able to widen out to other teams and domains. Yeah.
Any other questions?
What's your research data policy and how do you fund compliance with that? You have that policy in place since 2004, is it? How do you find compliance?
Well, I suppose you're looking at a 50-50 compliance rate really, and it's, there's often been, there's conversations over coffee that says, okay, we'll hold back the last piece of the grant until we get the data, but legally we just can't do that. Now that would probably make people sit up and say, okay, well, we need to comply. But more, it's a tricky one. It seems that people always comply with their financial rules and regulations, their timekeeping, their human resources, and it's almost the data and metadata are the poor relation. So so compliance is, it's good, but it's not what we want it to be. We'd like it to be better. There's a lot of chasing on the part of the EPA to chase that particular bit down, whereas maybe the research office in the university will chase a researcher to ensure that they have their financial reporting done correctly with us. But it seems that there's nobody there to push the researcher from that side to be data compliant.
So at the end, education, consultation, implementation. Who are you planning to consult with, and what do you expect the outcome to be?
Well, I suppose in terms of the data, collecting data from projects and then making it available. I think what we're wanting to do is to talk with other people who have experience of this and have had more success in doing it than we've had. In that, as I said, there's 800 projects funded. There's about 200 that have provided data to us. So it's not a great return on a big investment that we've had. So it's seeing that, are we asking for the wrong thing? Are we going about it in completely the wrong way? And is it a time for a change of thinking? Do we abandon the idea altogether of collecting data from projects, even though public money has paid for this, so the general public deserve to access those outputs? So, is it what is the best next step, based on other people's experiences?
Right. I think that's it for now. Thank
Okay,
you very
thank
much.
you.